Okay, I'm going to send you a copy of the notes, so print those out. If you haven't already done it, pause this and do that right now. And then we're going to learn today how to graph the sine and the cosine function. So as we know from the unit circle, a full rotation around the circle is 2 pi radians. So that is the period, meaning if we go around again, for example, if we had 13 pi over 6, the sine of 13 pi over 6 would still be 1/2. So we call that a periodic function when you can add something to it and get the same outputs. So looking at our sine function, the period is going to start at 0 pi and end at 2 pi. Now, we are going to be graphing in radians. This would be the same thing if we were graphing in degrees, but this would be 0 degrees and 360 degrees. But for the most part, like I've said, we're converting everything now to radians. Now, once you get the beginning of the period and the end of the period, you want to divide that into 4 equal parts. Can anybody think why 4 parts? Well, it's because of the 4 quadrants. Every time we get to one of the quadrantal angles, that's where the sine and the cosine switch signs. So we want to divide it in half, and then each one of those halves in half. Okay? If we take 2 pi, which is the period, and divide it into 4 parts for the quadrants, the length of each one of those segments is going to be pi over 2. So if we start at 0 and add pi over 2, we get pi over 2. 2 pi over 2 would be pi, and then 3 pi over 2. Now, because we are trying to graph sine, the inputs are the angles, and the outputs will be the ratio of sides. But since I'm only using quadrantal angles here, basically the output is going to be the y-coordinate of the ordered pair. So looking at the unit circle, the sine value, again, is the y-coordinate. So at 0, that would be 0. At pi over 2, it would be 1. At pi, it would be 0. And at 3 pi over 2, it would be -1. And then when we get all the way back around to 2 pi, it's going to be 0 again. So let me plot those points. 0 radians, 0 is the output. Pi over 2 radians, 1 is the output. Pi, 0 is the output. 3 pi over 2, -1 is the output. And 2 pi, the output is 0 again. Okay. Then looking at the values in the first quadrant, we go 1/2, rad 2 over 2, rad 3 over 2. Those are getting bigger as we go. So those are going to increase. And it's a nice smooth curve. Hopefully you saw that yesterday when we did the video from Khan Academy. Then as you get to pi over 2, the values start to decrease. But they're still positive because sine is positive in quadrant 2. Then in quadrant 3, the sine values become negative, but they're increasing. And in quadrant 4, they're negative, and they are decreasing. So that is one period of the sine function. We will do the same thing with the cosine function, but the cosine function, remember, the outputs are the x-coordinates. So when we go to graph the cosine function, we still start at 0. We go to 2 pi because 2 pi is the period. Then we divide that into 4 parts because of the quadrants. 2 pi over 4 is pi over 2. So each one of these is pi halves. But this time, the outputs go 1, 0, -1, 0. So we start at our maximum, then we have an x-intercept, then we go to our minimum, then we have an x-intercept, then we have our maximum again. So the cosine curve when you graph it, will look like this. Both of these curves are called sinusoidal curves because they look like this wave. If you took this wave and you extended it, because it is periodic, it's going to continue doing that motion. So we should draw arrows on the end, and we could do the same thing for the sine curve, or excuse me, the cosine curve. And notice that if we just took the sine curve and we shifted it right here, it would be the cosine curve. So the domain for sine is all real numbers. The range, -1 to 1. The sine function is odd because it's symmetric to the origin. The x-intercepts are all the multiples of pi. And the maximums and minimums are 1 and -1. So for the cosine function, the only thing that's different is that it's an even function, and its x-intercepts are pi halves, which is the first one, plus half the period n. And the maximums and minimums are still -1 and 1. So domain all real numbers, range -1 to 1. Let's take a break so you can think about that.